Today we're on page 7 of our Chapter 4 notes packet, Section 4.3, Linear Functions and Direct Variation. Some functions are one-to-one. This means that every element in the domain corresponds to only one element in the range, and each element in the range corresponds to only one element in the domain. That is, for each x, there's only one y, and vice versa. So each x has one y, and each y has one x, or no two ordered pairs have the same y value. Identify whether the following relations are one-to-one. Set containing 2, 2, 3, 3, 4, 4, 5, 5. Yes. Each x, only one y, each y, only one x. 1, 2, 3, 4, 5, 6, 7, 4. Oops. No. A y of 4 has two x's, right? 3 and 7. 1, 2, 2, 3. Yes. Each y has only one x, each x only one y. We can easily tell if a graph function is one-to-one by performing the horizontal line test. Remember the vertical line test to determine if a relation is a function? Well, in order for a function to be one-to-one, it must also pass a vertical line test. So number 4, we have this graph. Yes, it is a function. Does it pass a horizontal line test? Meaning if we draw horizontal lines, do these horizontal lines intersect the graph at only one point? Yes. So it is one-to-one. Passes the horizontal line test. Number 5, we do have a function. Right. Does it pass the horizontal line test to be one-to-one? No. It fails the horizontal line test. So it's not one-to-one. Number 6, is it a function? No, it's not a function, right? It fails the vertical line test. In order to be one-to-one, it first has to be a function. So in this case, it's not even a function. So even though if we were to draw our horizontal lines, yes, it would pass the horizontal line test, but it's not a function to start with. So it cannot be one-to-one. A linear function has a general form, linear line, right? Has a general form of the function f, where ordered pairs x, y follow the rule that y equals mx plus b. Is the graph of a non-vertical line a function? All right, well, think of any line, as long as it's not a vertical line. Is it going to pass the vertical line test? Yes. As long as it's a non-vertical line, it passes the vertical line test. Is the graph of a non-vertical line one-to-one? Only if it's not a horizontal line. Right? Because if we were to have a horizontal line, right, a horizontal line would pass the vertical line test, so it is a function. But is it one-to-one? All right? No, it's not one-to-one. It would fail the horizontal line test. So is the graph of a non-vertical line 1-to-1? Yes, only if it's not a horizontal line. Determine if the following are 1-to-1 and why. Okay, we have y equals x squared. Well, let's just do a quick sketch of this. Y equals x squared would be our parabola, right? It is a function. Does it pass the horizontal line test? No. It's not 1-to-1. Fails horizontal line test. 2, y equals 4 minus 3x. This is a graph of a line, right? Would have a y-intercept of 4 and a slope of -3, so something like this. Is the graph of this non-vertical, non-horizontal line 1-to-1? Yes, it is, because it is a function, and it passes the horizontal line test. Passes vertical line test and horizontal line test. Number 3, y equals the absolute value of x plus 3. Now, the absolute value function, right, is always the shape of a V. Let's see, this would be shifted to the left 3. So this would look something like this. And we could use our calculator, certainly. It fails the horizontal line test. Yes, it is a function, but fails the horizontal line test, so no, it's not 1-to-1. And number 4, x equals y squared would look something like this. Again, we would have to get y by itself. We would square root both sides. We would end up with something like this as a graph. Okay. This is not even a function. So no, it's not 1-to-1. All right. It fails the vertical line test, so it's not even a function. Next, page 8. Two variables vary directly or are directly proportional when their ratio is a constant. So we have, when varies directly, think of division or divide. We have y divided by x equals some constant k, or if we wanted to solve this for y, we multiply both sides by x and we have y equals kx. They are increased or decreased by the same factor. The graph of every direct variation example is linear, so it's a line, and passes through the point 0, 0, the origin. For y equals -x, graph the function. Is it a direct variation? Is it 1-to-1? And state the domain and range. Okay, so let's sketch a graph of y equals -x. You might recall from geometry last year that this is a diagonal line that bisects the second and fourth quadrants. So y equals -x would look like this. Is it a direct variation? Well, yes, it is a line that passes through the origin, so that's yes. Is it 1-to-1? Yes. The domain? No, it's all real numbers. And the range is also all real numbers. Okay, always back to our favorite word problems. A car is traveling at 45 miles per hour. How far does a car travel in 1 hour? Well, this is its rate. So the rate is 45 miles per hour. So rate equals distance over time is really what we're talking about here. All right. So if it traveled 1 hour, that would be 45 miles. 2 hours, add another 45 to that, we have 90 miles. 10 hours, Well, we just take our 45 and times it by 10. That'd be 450 miles, not hours. How long does it take for the car to travel 135 miles? All right, well, 135 miles divided by 45, that will bring us to 3 hours. 180 miles divided by 45, that's 4 hours. 405 miles divided by 45 is 9 hours. So we could actually represent this as 45, our rate, is equal to miles over hours. So 45 is our constant. So is this an example of direct variation? Yes, it is. If the car drives for 10 hours, what are the domain and range? All right. Well, for 10 hours, that was 450 miles. And our time, or hours, is 10. So m is our y, miles is y, or distance is y, and time is x. So we have y over x. So domain, I'll just put D for domain, is the set of all values of x, such that x is less than or equal to 0, greater than or equal to 0, or less than or equal to 10. We could write that in interval notation as 0, 10 in brackets. Our range, put capital R for range, the highest number of miles we would have traveled is 450, and the lowest would be 0. So our range would be the set y greater than or equal to 0 or less than or equal to 450. Or again, in interval notation, 0, 450 in brackets. Another example, Jacob can type 55 words per minute. So the 55 words per minute, that's his rate. So 55 equals words per minute. Write a function for the relationship between words and time. There it is. Is this function one-to-one? Yes. If he types no more than 2 hours, what are the domain and range? Now be careful here. 2 hours. Our equation or our function was in minutes. So first, 2 hours is equivalent to how many minutes? It's 120 minutes, right? So our domain would be 0 to 120. And our range how many words? Well, if we take 55 is equal to words over 120, what's 55 times 120? 660. So our range is from 0, or rather to 6,600. And this completes our video for tonight.